Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1 and same chapter matrices with different topic, solution of system of non-homogeneous linear equation. Okay, so system of non-homogeneous linear equation and how we can solve. Let's have a look. Which system is known as a non-homogeneous linear system? To understand this, we have a system of m non-homogeneous linear equations in n unknowns. Unknown, that means variables, is represented by this: a11x1 plus a12x2 plus a1 up to plus 1 a1 n xn is equal to b1. Because of this b1, that is non-zero number, this equation known as non-homogeneous linear equations. And we have the total m equations and n variables, n variable x1, x2 up to xn variables, and we have m equations. This matrix, this system can be written in the matrix form Ax is equal to B, like capital A becomes the coefficient matrix. That means these elements A11, A12 up to A1n, A21, A22 up to A2n, and up to so on AM1, AM2 up to AMN. Okay, this capital X is our variable matrix. That means variable, that means x1, x2 up to xn. That capital B is constant matrix which is equal to given b1, b2 up to bm. So we have this matrix form. This capital A, this is x, and this is b. We have Ax is equal to b. Now we have solution of system of linear equation. How we can find the solution and how many solutions are possible? So for system of m linear equation in m unknown, there are three possible solution of the system for non-homogeneous system. Okay, we have three possible solution. Number one, system has unique solution. That means we will find the answer only unique. That means x1 is 1, x2 is 3, x3 is minus 1 or something else. That means different answer, only single answer. We will see by example. Infinite many solution, also understand by example. And third is a system has no solution. These are the three possibility, and how this will happen we'll understand by the example only. When the system of linear equation has one, that means unique, or more solution, that means infinite solution, that system is known as consistent system. And if system has no solution, then system is called inconsistent system. So consistent, that means system has solution, either it is unique or it is many. But inconsistent system, that means system has no solution. Okay. Now linear system has a unique solution if determinant of A. What is A? That we know, that coefficient matrix. If determinant of coefficient matrix is non-zero, then system has compulsory unique solution. Okay, this is the one remark that we have to keep remember. Okay, now we have this matrix A and B, combined matrix. This is coefficient matrix and this is constant matrix. We will combine these two matrices. First row is the entire first row. The second row, just we separate by this dot. Okay, just we have separated by this dot. You can put dot or you can put this line also. And this matrix is known as augmented matrix. You have to keep remember. Augmented, that means when two matrices are combined, this becomes augmented matrix of our non-homogeneous system. Okay, and by solving this non-homogeneous, that means augmented matrix, we will find the solution. So to solve system of linear equation, elementary transformation are used to reduce the augmented matrix to either row echelon form or reduced row echelon form. That means we will apply elementary row operation only to convert this combined augmented matrix AB to either of this form, row echelon form or reduced row echelon form, according to the method. So we have first method is Gauss elimination method. Okay, and in this method we will convert the augmented matrix, okay, or we will reduce the augmented matrix into a row echelon form, and this method is called Gauss elimination method or Gaussian elimination method. Okay, after reducing these, and what are the steps? So to understand that, we have to follow this step. Number one, first write down the augmented matrix. How to write down augmented matrix? I have given matrix form. In matrix form, capital A and capital B will just combine, and that matrix become augmented matrix. Then by obtain row echelon form of the augmented matrix by using row operations, only row operations. As I told in previous lecture, column operation is used only in normal form. Okay, so find row echelon form of augmented matrix. Then after getting row echelon form, write down the corresponding linear system. That means again write down the equation from the matrix. Equation is given. See, equation is given. You write down the matrix form, then find augmented matrix, then find the row echelon form. After getting row echelon form, again write down that row echelon form into equation, and after solving that equation by solving the corresponding linear system which is obtained from the row echelon form, and by back substitution method we will find the solution. Simple. These are the steps. Same step will be applicable for the Gauss-Jordan elimination method. Okay, Gauss-Jordan elimination method. But in Gauss-Jordan elimination method, we will reduce the given matrix, the given augmented matrix, which is obtained, into reduced row echelon form. That means we have to reduce in RRE form. So in Gauss elimination, that is Gaussian elimination, we will reduce augmented matrix into row echelon form, and here we will reduce into reduced row echelon form. Other than that, there is no change in process. We have that step, augmented matrix, reduce into reduced row echelon form, then by applying row operation only, then corresponding system, and then by solving corresponding system, we have the final answer. Okay, so how we will write down the examples step? Let's have a look on the example. First example, solve the following system by Gauss elimination method. Gauss elimination method, that means we have to reduce augmented matrix into only row echelon form. Okay, and system is given by these three equations: equation number 1, equation number 2, and equation number 3. First of all, we will write down the given matrix, given system into matrix form. So we have solution. The matrix form Ax equal to B of the given system is 1, 1, 2, 2, 4, minus 3, 3, 6, minus 5. This is our matrix A. X, Y, Z in column, because these three are our variable, and is equal to 9, is equal to 1, is equal to 0 is our matrix B. Okay. Now find augmented matrix. Augmented matrix, that means combination of this A and B2 matrix. So augmented matrix of the system is AB. AB, we can say AB. A is to B is not known to say. AB is equal to this A and this is B. Always the number of rows are equal in this A and B, because you know that we have three equations. Okay. Now reduce this matrix. Now consider this is one single matrix, and reduce this matrix into row echelon form. So we have this is 1. By applying row operation, R2 minus 2R1, R3 minus 3R1. Okay, we have this first step. We are starting with the AB, R2 minus 2R1, R3 minus 3R1. We will find A1, 0. Now to make this 1, divide by second row by 2. So 1 by 2, R2, 1 by 2, R2, So this become 1, this becomes minus 7 by 2, and this is minus 17 by 2. So we have this, and third row as it is, first row as it is. Now, by applying which operation? So pause the video and find out the row echelon form. Okay. So we have operation R3 minus 3R2. As I told, we will use second row. Okay, R3 minus 3R2. So this 3 becomes 0, and this minus 11 is reduced to minus 1 by 2. Minus 27 becomes minus 3 by 2. How? So we have this operation R3 minus 3R2. Now we want to change this third row into this. So this will be 0 because of this operation. So 3 is 0 by default. Now minus 11. R3 that means minus 11 minus 3 as it is. R2. R2 that means just above this in place of R2. That means minus 7 by 2. By simplifying minus 11 minus plus, there is no any term which will be cancelled out. So we have 21 by 2. By taking LCM, minus 22 plus 21 whole divided by 2. So we have minus 1 by 2. This is our this. Similar way we can find minus 11. Now this is 1, this is 1. Now we have to make 1 here. For that we will multiply minus 2 R3. So we have this step minus 2 R3. So this become 1 and this become 3 because here minus 3 by 2. So minus 3 by 2 into minus 2 into cancel, minus cancel, we have 3. So we have 1, 1, 1, and this is finished. Now this is our row echelon form. As we have decided, after getting row echelon form, we will write down the corresponding system of equations. So corresponding system of equation, that means we will apply x, y, z to this. X plus y plus 2z is equal to 9. This number 1. Second, x is 0. So y minus 7 by 2z is equal to minus 17 by 2. This one. Third one, z is equal to 3. So this one. We have these 3 equations. By solving this equation, how? We have z is equal to 3. We will put this into equation number 2. We will find out. We will have y. So put z is equal to 3 in equation number 2. So put here. So y minus 7 by 2 into 3. By multiplying, simplifying, this is 21 by 2. By taking on the right side plus 21 by 2, and we will get y is equal to 2. By putting y and z in equation number 1 here and here, we have value of x. So simple. Okay, so we have this x is equal to 1. So we have final answer, x is equal to 1, y is equal to 2, and z is equal to 3. This is the unique answer. Other than this 1, 2, 3, there is no any solution. That's why this system has a unique solution, as we can say. Okay, so how we started example and how we finished, you understand? Now we have second example. And what is the second example? Solve the given system by Gauss-Jordan elimination method. Gauss-Jordan, that means we will reduce the augmented matrix into reduced row echelon form. So simple. So same example I am going to take, same example as previous, just I am changing the Gauss-Jordan elimination. So no need to waste our time. We are just going to it quickly. Matrix form, augmented matrix. We have AB is equal to given by this matrix, and by reducing this into reduced row echelon form. So let's start with the matrix AB. So we have this AB. I'm just writing again. First we will find the row echelon form as the same previous, R2 minus 2R1, R3 minus 3R1. We have this by dividing second row by 2, the 1 by 2 R2. We have this minus 7 by 2, minus 17 by 2. So this is 1. Now making 0 here. So we have R3 minus 3 R2. Okay, this one. So we will find this 0 and this minus 1 by 2, minus 3 by 2. How? We already seen in previous example. Now making 1 here. So multiply with minus 2 R3. So we have minus 2 R3. So we have this matrix. after getting this is our row echelon form. Now reduce this into reduced row echelon form. How? We know after getting row echelon form, start from the right hand side. So from here to here to here. So we will make this two number 0, two element 0. So first 0 this by using the third row. So R1 minus 2R3 and for second R2 plus 7 by 2 R3. We have this. Okay, R3 is fixed now because we are using third row. So we have third row as it is. First we write down third row. Now apply on the first row by using this first operation and on second row by second operation. So only change this to 0 and this 2 number is changed here. Okay, how? So first operation is this R1. R1 that means 9. So 9 plus minus 2 into R3. So in first row, in same down to the 9 we have 3. So here 3. So we have 9 plus minus 6 is 3. Similar way we have R2. R2 that means this minus 17 by 2 plus 7 by 2 into R3 that means 3 again. So we have minus 17 by 2 plus 21 by 2 which is by 2 and which is 4. So which is our 2. So this is our 2. Okay. Now I'm doing this so you can check later. Now we have this one, leading one. These are the zeros. Now we have to make 0 here. This is R1. So first write down R1. We are using R2. Second row we will use. So R2 and minus. So R1 minus R2. R1 minus R2. Okay. So we have this is our reduced row echelon form. Each column that contains leading one, in that column other that one, all the elements are 0. This is not leading one's column. Okay. So we have directly, we can see x is equal to 1, is y is equal to 2, z is equal to 3. Okay. Simple. So the solution is x equal to 1, 2, 3. Answer is same, but just we are applying here reduced row echelon form because of Gauss-Jordan elimination method. Okay. So now one more example we have, so you can understand better. Solve the following system by Gauss elimination. That means you have to apply, yes, only row echelon form. We have 1, 2, 3 equations. So first we will write down in matrix form. So we have this Ax is equal to B. Then we will find augmented matrix A and B combined. So this is AB combined matrix. Now this is our Gauss elimination method. So we will reduce this matrix into row echelon form and start with the AB matrix. So first we will start with the 1 by 3 R1. You can check this matrix again. We have this make 1 here. So 1 by 3 because there is no any 1 in this column. Otherwise, you can change or interchange the row, but we have no any option. So 1 by 3 are 1. Second row and third row as it is, entire row as it is. Check it out. Use pen and paper so you can understand better. So 1 by 3, if we multiply 1 by 3, so 1 by 3 minus 1 and 13 by 3. So we have this 1 by 3 R1 and we have this. Okay, second and third row as it is. Now apply row operation to this and this second and third row. So R2 minus 2R1, R3 minus 2R1. So R2 minus R1, R3 minus 2R1. Now we have by applying these operations, how we can apply, we know that for second row we will apply R2 wala operation. Third row R3 wala operation as we have discussed in previous lecture. So go with the previous lecture again, then start this lecture. Okay, so we have this. This is 1. Now we want to make 1 here. And in this below, element is no 1. So we have to divide this by reciprocal of this. That means we have to make here 1. We will multiply 3 by 11. So 11 cancel, 3 cancel, but minus is here. So minus. So minus 3 by 11 of R2. Done. So multiply this entire row R2 by minus 3 by 11 with this also and with this also. We have this. This is 1 or this is 1 because these both are same. And here 9 into 3 by 27 minus 27 by 11. Now for this we have operation R3. We will use R2 55 by 3 and minus. Okay, sorry. And minus. So it this. Okay, so minus. So this becomes 0, and for this we can check the operation. So we have this operation R3 minus 55 by 3 R2. Okay, so we have this, and by applying this we have 0, 0, this 3 0 is equal to 5. Now to make in row echelon form we have to convert this into 1. If we cannot convert, then it's okay. If we are not converting, it is okay, because this 3 term is equal to 0. It's not possible, because 0x plus 0y plus 0z is equal to 5. Is it possible? 0 is equal to 5? No. That means system is inconsistent and system has no solution. So this is second type of example. Okay, so last row of the augmented matrix from the left is 0. So 0 is equal to 5 is not possible. System is inconsistent and system has no solution. So in this lecture we have seen as we have seen that system has 3 type of possibility of solution: unique solution, many solution, and no solution. We have seen the example of unique solution. We have seen the example based on the no solution. Now one method is remaining, infinite many solution, that we will see in next lecture. So we have this example for your practice, and out of this example you can have any of the example is from that second possibility, that infinite many solution. If you have idea or you have knowledge, basic knowledge, then you can apply, and if you don't have that knowledge, then check the next coming video. Okay, just use pen and paper, and after reducing into row echelon form and finding the corresponding system, you can understand which example is of unique solution, no solution, and many solution. If you don't have any idea, then leave the example at that point, and after completing this lecture, next lecture will be give you the idea about the infinite many solutions. So thank you for watching this video. We will see you soon with the next lecture. Thank you very much.